Good afternoon. I think mostly 2 students I'm able to find, 2 or 3 students. Right?
Yeah, you please carry on, sir, so that they will join.
Okay. We'll start with the topic. Actually, I want to share the screen. I told to the people to make me give me the chance to share the screen. 1 second. So yesterday we discussed about the basic measures of central tendency. Now we are going to discuss about the measures of dispersion or a variation. So within a while, I'll share the screen. The sharing the screen is not the possible. Host disabled participant screen sharing. He says it is saying.
You please contact the host, sir.
Yeah. I contacted. I told them.
They are providing
They said,
sharing option to all the faculty.
yeah, I did the same thing yesterday also. I told
Yeah.
after Measures of central tendency, measures of dispersion, where the dispersion is nothing but whatever we calculated the central value which describes the complete data we said. So that complete data is scattered one, or whether it is properly managed one or not, to identify the additional calculation will do whatever the average we are calculating, or a mean median mode, is that mm, what we can say is suitable. Yes. Yeah. Actually, I want to share the screen, but it is not getting. Once again, I'll talk
Yes,
to
sir.
them.
It will come. It will come, sir.
Okay, okay,
It
sir.
will come. Yes. Yeah. You can able to share now. It is done now. Yeah. You
No,
are a
sir.
co.
Host disabled participant screen sharing.
Okay. Okay. One
Still,
minute, sir. I will just do. It is. I think miscommunication. I will just. Sir, you can share now, sir. Sir, you can share it now, sir.
am I audible to you?
Yes, sir. Yeah.
Yeah. Is the screen is visible, whichever I'm showing it?
Right. Yeah.
Right. Okay. Thank you. As I told you, the second thing about the variation part, that is measures of dispersion, we can say. This is what measures of central tendency reflects a single numerical value, describes the entire data we discussed in the previous, but it cannot indicate the extent of variability in a distribution. That is, it cannot reveal this scatteredness in the data. Means how much increase, how much decrease, what difference is what we are getting it as a less than average or more than average, whatever the values. So the measure of dispersion reveals the degree of scatter of values in a series from its average value. It can also be said as averages of the average. So whatever the average we'll calculate, again we are doing one more average and finding out the difference. That is the variation, whatever is there in the average calculation, that we are finding out here. And apart from that, we will measure the skewness. Skewness means what is the determine whether a distribution is symmetrical or asymmetrical. Means whether it is similar, all the mean median mode are the same, or else is it not same, that means not equal. So if all the three values are equal, that means we can say the data is symmetrical. So the distribution, whatever the data is available, is a symmetrical. Otherwise, it is asymmetrical. Then we can find out the skewness. That measurement of skewness we can find out after finding out the dispersion. So to find out the dispersion, we have the study of dispersion is of great significance in practice, as could be well appreciated from the following examples we can say. So like series A, B, C is given to us, where the totals of all the series is same 360, 360, 360. If you divide it by number of observations, the value of mean for all the three series is same. Since arithmetic mean is the same in all the three series, but three distributions differ widely from one series with the other. You can check. First one is all 40s. Second one is 40 or more than that or less than that. Series C is totally up and down. It's a very differences between the data. So in series A, every item is perfectly represented, but there is no dispersion in the series A. In series B, only one item is perfectly representing by the arithmetic mean, and the other items vary, but variation is very small as compared to series C. So in series C, not a single item is representing by the arithmetic mean, whatever we got as a mean as 40. And the items vary widely one from the other. So in series C, dispersion is much greater compared to series B. So series A doesn't have any variation, so there is no dispersion. Whereas series B, there is a dispersion, there is a variation, but slight. But in the series C, a lot of differences in each of the values. So that means it is having a somewhat dispersion. So that dispersion, we are measuring it by means of measures of dispersion. So that measures of dispersion is having different purposes actually. Dispersion required for the four basic purposes. The measures of dispersion point out whether the average of the series is represented by of the distribution to determine the reliability. So when the dispersion is small, the average is closely representative of the distribution. Whereas the dispersion is large, the average not reliable, and unless the sample is very large, and the average may be quite unreliable. And the other one is to serve as a basis for the control of the variability. That means how much differences you have to control over it. You can use this measures of dispersion. And the measures of variable enables comparison to be made of two or more series with regard to their variability. Means how much differences you are getting it in the measures of dispersion, that much variation you will be finding out in the series, or that means the data. An analytical tool like correlation analysis, regression analysis, and analysis of variance, testing of hypothesis, etc., are based on the measures of dispersion only. That means after finding out the dispersion only, we can find out the further values, that is correlation, regression, analysis of variance, or the testing of hypothesis. This is possible after finding out the dispersion. That means measurement of dispersion. So to measure the dispersion, there are so many methods. One is positional measures, another mathematical, or the graphical. If you go with the positional, there is there are two things. One is range, another one is interquartile range, or else we can say as a quartile deviation. Interquartile range, or also known as a quartile deviation. Whereas mathematical measures, there is a mean deviation and the standard deviation. Graphical representation is also there as a Lorentz curve, how much the variation in the data, which can be represented in the graph. So we are going to discuss about the positional mathematical to find out how to find out and how to calculate. So that is actually the thing where the positional measurement of dispersion, we have range is one as a simple one, and another one quartile deviation, which is based on the median calculation part. So first is about the range. If you go measures of variations, it is the simplest method of studying the dispersion. A range is the difference defined as the difference between the value of the highest item and the value of the lowest item of the distribution. So we can say symbolically as largest item minus smallest item is absolute measure of range. That is the range we can say. Whereas the coefficient of range, that means the variation whatever we are calculating, that is based on the coefficient. So coefficient of range is L minus S by L plus S, means largest value minus smallest value divided by largest value plus smallest value. So the data may be any series, as we discussed. The total data, if it is less number of observations, then it is individual. More, than it is discrete, or else unlimited, we can say continuous series. So that here for the individual series, if you see, the compute the range and its coefficient from the data given below. So data is clearly mentioned as an individual values. The data can be a salaries of an employee or a marks of a student or anything. Any data, that data is individually mentioned as an individual series. And then from this data, what we need to do to find out the range and coefficient, a smallest value and the largest value. So in the total data, the smallest is 160 and the largest is 360, right? So largest value 360 minus smallest value 160. The difference is your range, nothing but 200. But the coefficient, to calculate the coefficient, what we'll do? So coefficient of range is nothing but L minus S by L plus S. So 360 minus 160 divided by 360 plus 160. So 200 divided by 520, that is 0.38. It means there is a variation in the distribution about 0.38, 38% we can say, assume to be, and 38. So 0.38 is the coefficient of range. This is about the individual series. If it is a discrete series, as I told you, the data, that is the observations, whatever the X values are there, that observations, from that the largest value is 70 and the smallest value is 10. So the difference in these two is nothing but the range, and the coefficient is L minus S by L plus S. You are getting a 70 minus 10 by 70 plus 10, that is 60 by 80 is 0.75. So whether it is either discrete series or continuous series, we need to consider only the observation, that is the variable part. Even for the continuous series, if you go in the class interval, the smallest class, the lower limit of the smallest class and the high limit of the upper limit of the highest class. So that only to be considered here as the largest item and the smallest item. So the largest item in this class interval is 700 and the smallest is 100. So the difference is your range, L minus S, and the coefficient is L minus S by L plus S. Again, it is same as 600 by 800 is 0.75. So that is about the range. The range method under the dispersion is the simplest to understand, but easy to compute it very less time. But it is not based on each and every item of the distribution. That is the disadvantage here. The range cannot be computed in case of open-end distributions. It is subject to fluctuations of considerable magnitude from sample to sample. So mostly the people won't consider this range calculation part, very less, where the data is accurate without open-end classes, and exactly of individual series, we can say it can be applied, not for all things. That
Sir,
is
small
the
question,
first
sir.
method.
Yes,
Yeah.
sir. What is the significance difference between range and coefficient of range, sir? When we are going to use range, when we are going to use coefficient of range in real-time situations?
See, sir, mostly the range is nothing but ability, how much able to get it, like the you can see here the usage of the range, the studying the variations in the price of the gold, stock, shares, and other commodities which are sensitive to price changes from one period to another period. At that moment, we can use this range values. That is the difference. The
Coefficient?
difference is when you have the coefficient, where you can apply to find out whatever the averages we calculated with the series, that series having somewhat differences. The difference in the sense, the scattered data which we are showing it, which may not be accurate one. The average is not giving the accurate value. That variation, how much variation in the series is, just now we discussed that series A, series B, series C. So that series
Yeah.
having a lot of difference, but the mean is same. So at that moment, the coefficient is useful for the finding out the variation. So that
How do we
dispersion,
interpret that coefficient value, sir? How do we interpret that coefficient value in the conclusion?
that's what the conclusion part, when you are considering only the coefficient of a range is considered to show that there is a difference in the series of the data. How much difference you are getting, it means the coefficient whatever we calculated just now as 0.75, it is giving as a 0.75. That means 75% there is a variation in the data of observations.
From
If it is 0.25 from each of the value, that means the calculated series, whatever series we have calculated,
okay,
that is the coefficient of range, or coefficient, any coefficient of dispersion. That means any coefficient of dispersion methods we are calculating, that is applied to find out how much variation you are having in the data.
okay,
So similarly, we have another method called as quartile deviation, which is known as interquartile range. So the range is based on two extreme values, but it is not based on each and every item in the dispersion or the distribution, which we discussed just now. Whereas the value of range failed to take out account on the scattered within the distribution. So therefore, another measure is deployed or developed to overcome the measure of ranges, interquartile range. So this is normally called as interquartile range because quartiles are used. So interquartile range represents the difference between the third quartile and the first quartile. So third quartile and the first quartile. So upper quartile or lower quartile, we can call it as another way. But interquartile is nothing but the difference between these two things, Q3 minus Q1. Whereas semi-interquartile range, nothing but the quartile deviation which we'll calculate, that is Q3 minus Q1 by 2. And for the absolute measurement, we'll apply the quartile deviation only. Whereas for the coefficient of quartile deviation, as I told you, the coefficient is calculated to find out the variation or deviation in the actual data. That is Q3 minus Q1 by Q3 plus Q1. So most of the time, this coefficients you should get as in the decimals. If it is you are getting or more than decimal values, that means your calculation having somewhat mistake and you did some error and the solution is wrong. So to find out this interquartile range or quartile deviation or coefficient of quartile deviation, we need to find out Q1, Q3. What is Q1? Lower quartile. Q3, upper quartile. So it is a quarter. Quarter means 1/4 area. So we are taking a 1/4, 4 parts we have made it. So first 2 parts and second 2 parts. That data we are finding out as a Q1 and Q3. From that data, we are averaging it and finding out the deviation. That deviation or dispersion, we are getting it by means of this quartile deviation. So here, to find out the Q1, what we need to do, we need to arrange the data in the ascending order. That is the first point, what we discussed in the median. The same thing for the quartiles. So everything is to be applied for the quartiles. First, we need to find out, arrange the data in the ascending order. Then total number of observation, that is for the individual series, n plus 1 by 4. n plus 1 by 4. How many items are there here? 1, 2, 3, 4, 5, 6, 7, 8. 8 terms are there, 8 items are there. So 8 plus 1 by 2, nothing but 9 by 2, nothing but 4 by 4.5, you'll be getting it. So 4.5 is nothing but fourth item. Sorry. N plus 1 by 4 we need to do. So 9 by 4 we need to calculate. If we calculate 9 by 4, how much you'll be getting? So there are the 8 items here, right? So 8 plus 1 by 4. Because quartiles we are finding out. So divided by 4. So 9 by 4, if you do, you'll be getting 2.25. Am I right? Yes. Am I audible to you?
Yeah.
Yes, sir.
Right. So what I mean to say is, calculate this Q1 and Q3 for the individual series. We need to observe the number of items here. Number of observations are 8 plus 1 by 4. If you calculate 9 by 4, you'll be getting as 2.25. That means second item plus 0.25 of third item minus second item. So second item is 20 plus 0.25 of difference of third and second item. So 30 minus 20 is 10. 10 divided 10 into 0.25 is 2.5. So 20 plus 2.5 is 22.5, like this. Q3 is also calculated in the same way. That is 3 into n plus 1 by 4. 3 into n plus 1 by 4, that is nothing but
6.75.
6.75. So sixth item plus 0.75 of seventh and sixth item difference. So sixth item is here 60 plus 0.75 of 70 minus 60 is nothing but 10. 10 into 0.75 is 10, 7.5. So 60 plus 7.5 is 67.5. That is Q3 and Q1 calculation part. So after calculating third in the first quartile, you can calculate interquartile range, semi-interquartile, or coefficient of quartile division. So interquartile range is Q3 minus Q1. The difference of these two things, 67.5 minus 22.5, 45. And semi-interquartile, that is half of it, is 22.5. Coefficient is again Q3 minus Q1 by Q3 plus Q1 is 0.5 you are getting. So that means there is a variation in the series is about 0.5. So to calculate the quartiles, quartile deviation, the series may be any way, that is individual or discrete or continuous. The same like a median. So when it is given as in the discrete format, what we'll do, X is an observations, frequency F is frequency. We'll find out the cumulative frequency, accumulating all these frequencies. The total of frequencies is 80. 80 divided by 80 plus 1 by 4 for the first quartile. So 80 plus 1 by 4, if you calculate 20.25. Right. So that 20.25 appears in this cumulative frequency in 30. So straight to this, whatever the observations are there, that is your exactly the Q1. That is Q1 is 30. Whereas for the Q3, n plus 3n plus 1 by 4, calculate, you are getting us 20.25 into 3, 60.75. So that appears in this one as in the 70. So straight to this observation X is treated as a quartile 3. So Q3 is treated as 60 here. So Q3 is 60, Q1 is 30 we got. With that we can find out interquartile range is Q3 minus Q1, that is 60 minus 30 is 30. Semi-interquartile, that is quartile deviation, is Q3 minus Q1 by 2 is 15. Coefficient is Q3 minus Q1 by Q3 plus Q1, that is 0.33 we are getting. Similarly, for the continuous series, you see the continuous series, there will be a class interval and the frequency, where we'll apply here is the formula as a formula to be applied, same like a median L plus n by 2, we'll call it as for the median, but here n plus n by 4 for the first quartile Q1, for the third quartile n plus 3n plus 1, 3n by 2, so 3n by 4. So procedure is same. First we'll calculate cumulative frequency. The total of frequency is 80. We calculate n by 2, that is 80 by 2 is nothing but 40. 40 is appearing in this cumulative frequency as 50. Straight to this class interval 40 to 50 is your actually the first quartile lies.
No, it's median class. It's not first quartile.
First quartile, if you calculate n by 4,
4.
that is 20 you are appearing. 20 lies in this 30. So straight to this 30 to 40 is your quartile class, first quartile class. So lower limit is 30. The difference of class interval I is 10. Frequency F is 15. Preceding to the cumulative frequency is 15. So the calculation part which we learned in the median, similar like that, we need to calculate for Q1 and Q3. Only the difference is where the Q1 lies and Q3 lies. That is calculated by means of n by 4 and 3n by 4. Right? So need to find out first Q3, Q1, upper quartile, lower quartile, then we can find out the other values. Quartile deviation, coefficient of quartile deviation. So you can see here as a quartiles or quartile deviation, the advantages are can be used in case of open-end distributions also, skewed distributions also. It can be useful where the superior to the range. That means a range is very simple one, but quartile deviation shows in most of the time accurate one. Is not affected by the presence of extreme values. Where that this is also having somewhat disadvantage. That their demerits gives us QD ignores 50% items because that is first 25% and the last 25%. Q1 is first quartile, Q3 is third quartile. Okay, therefore it does not based on each and every item of the distributions, and it is not treated as good measure of dispersion because it is a positional based on the position. So it cannot capable of mathematical manipulation. Its value is very much affected by sampling fluctuations. So this measure is not often useful for statistical inferences because it is based on the positional average, as I told you, but not on the average. So what other people prefer is, instead of going with the quartile, we can go with the actual dispersion is based on the mean deviation. That is mathematical dispersion is mean deviation and standard deviation. So standard deviation is the perfect one, we can say, where this concept was introduced by Carl Pearsons in 1823. It is most popular and widely used measures of dispersion. Its significance lies in the fact that it is free from those defects from which earlier methods suffer and satisfies most of the properties of a good measures of dispersion it is having. So standard deviation is also known as root mean square deviation, for the reason that it is the square root of the mean of the standard deviation from the arithmetic mean. So it denoted by the Greek letter as sigma. You can see the sigma represented by sigma, where mean is represented by x bar, but here standard deviation is expressed by sigma. So the greater the amount of dispersion, the greater the standard deviation. And the smaller standard deviation means a high degree of uniformity of the observations, as well as the homogeneity of the series. This you need to remember while concluding it. If the deviation is more, that means that there is a greater dispersion, the greater deviation in the series. If it is small standard deviation means the higher degree of uniformity. That means homogeneity of the series is more. So to calculate, we must have an idea about how to calculate the mean. Actual mean and assumed mean means direct method and indirect method. Whatever we did in the calculation of arithmetic mean, the similar thing we need to apply here also. So the standard deviation calculation by taking a deviations from of the items from actual mean or is from the assumed mean. So if it is from the actual mean, the formula is this one, as simple one, under root of sigma x square by n, where x stands for the deviation between x minus mean, means actual observations minus the average of it. That is the actual mean. So what we need to do to find out the standard deviation in this individual series, the actual mean, first we need to calculate the actual mean of the series. That is x bar we need to calculate. Take the deviations of the items from the mean, that is small x equals to x minus mean, x minus x bar we can call it as. So whatever the average we are getting, the difference of actual observations with the mean, we'll be getting on a small x, which x denoted as a deviation from actual mean. So that value, whatever we are getting as x, square of it, that is square these deviations and obtain total, that is sigma x square. That sigma x square divided by number of observations, square root of it is treated as a standard deviation. So when we are calculating with the actual mean, directly under root of x square, sigma x square by n, whereas from the assumed mean, under root of sigma d square by n minus sigma d by n whole square. This is for individual series. So individual means the observations will be single observations for all the people. It may be a student's marks, salary of a people, or an observation observed for the any organization. We can call it as X as an observations. So what we'll do for the actual mean method, first we'll calculate the mean from the observations, total x, that is sigma x divided by n, is your mean that you got as 24. Difference between these x and mean. X minus mean is small x, that is the x values whatever we are getting it as difference of x minus mean. These differences square we need to do, that is x square. That total only we require. When we do the x square, the minus becomes plus, all the values will be in the positive, add total sigma x. So under root of sigma x square divided by n. N again the number of observations here. Until the frequency getting, we'll treat it as x as an observations number of items. Whereas from the assumed mean method, if you go, d is calculated. What is assumed mean? Any value from the x observations you can take and you can find out the deviation. That is the difference between x minus a. A assumed here as 20, so that values which we are getting, 24 minus 20 is plus 4 plus 6 plus 9 plus 5, 19 minus 20 is minus 1, 20 minus 20 is 0, 10 minus 20 is minus 10. So this d square we need to do. So d square, this d square total and d total we require, where a is already assumed. So from this, what we need to do, we need to find out the deviation. So deviations, after finding out the deviation, we can go with this sigma d by n, sigma d square by n, and a sigma d by n whole square. This is the formula to be applied for the assumed mean method. Under root of sigma d square by n minus sigma d by n whole square. So d square we got 516 divided by n is 10. Sigma d is only 40 by 10 whole square. So 40 by 10 is nothing but 4. 4 square is nothing but 16. So 516 minus 16. After doing it, you need to find out the square root of it. That square root is your actual deviation, standard deviation. Whereas coefficient of standard deviation, we can call it as coefficient of variance. Coefficient of variance or CV, we can calculate by calculating this mean and standard deviation. Standard deviation by mean into 100, you'll be getting a coefficient of variance or coefficient of standard deviation. So mean is 5.75 calculated here, divided by standard deviation. Standard deviation divided by mean into 100. If you do, you'll be getting in percentage or else in the decimal. If you do into 100, you can exactly tell how much percentage there is a variation. So that is CV, coefficient of variance. So mostly coefficient of variance is useful when there is a comparison between two companies' products, like two companies' refrigerators, as which company's refrigerator gives more life, which company's product gives more life while we are using it. So that can be applied here. This can be applied there when we are comparing the two companies' products, similar products. Right. As we know, we can calculate even with the step deviation method as a mean. So here also we can calculate standard deviation also with the step deviation method. So here in the discrete series, they calculated direct method, that is actual mean method, or assumed mean method. Both the ways they calculated. First, calculating with the actual mean method, x and the f given to us, f into x, if you do sigma fx by n is nothing but frequency total. If you do it, you are getting a mean, that is 54. That 54 is applied here and finding out the X value, the deviation between observations and actual mean. So that X, whatever we got, square will do it, X square, then multiplied with the frequency, you are getting as Fx square. So we require both the things, sigma Fx square and sigma Fx. So where the direct mean method, under root of sigma Fx square divided by n or sigma f for the same. So under root of 31,400 divided by 100, you are getting us 314. Under root of 314 is 17.72. That is standard deviation, and the mean is 54. Standard deviation by mean into 100 is your coefficient of variance or coefficient of standard deviation. That is 0.33. That is actual mean method. Here they calculated by means of assumed mean. Means D is there. So D FD FDX square. FDX square. Even for the continuous series also same, but there is a slight change here.
Hello, sir.
Yeah, yes.
Problem 8.9, x mean 54. Last sum, x mean 24. How to know, sir?
This one you are asking?
Mean 54. Last sum is 24. How to know?
See, this 54 we got by means of the series. That is here the discrete series question. It's not the same one. The previous one is only individual series. This is about individual series. The single X observations are there. Individual series means what? Only individual values are given without frequency. Right? So this total X divided by n number of observations. So total of X is 240 and number of observations are 10. So if you divide it here, you can find out mean equals to 240 divided by 10 is 224. That is the actual mean in this individual series. Whereas here there is a discrete series, means what? X and F, income of the people and number of persons falling in this income. So this number of persons whenever is mentioned, that is a frequency. The people falling under these groups, these observations. So when it is a discrete series, the calculation of mean is what? Sigma Fx by n. So sigma Fx means what? This frequency is multiplied with x. This income is x. So 20 into 5 is 100. 30 into 10 is 300. 40 into 20, 22 is 880. So if you calculate, that is Fx, that total is 5400. Sigma Fx divided by n is 100. So 5400 divided by 100 is nothing but 54. That is what here he calculated and shown. Mean equals to sigma Fx by n. 5400 by 100 is 54. This 54 is applied to find out the difference. That is deviation or the X. Right?
Okay, sir. Thank you, sir.
Sir, one question, sir.
Yes.
We are going to discuss about these three methods: step deviation method, direct method, and indirect methods.
Right.
So in the examination, which method we have to follow?
See, it is not mandatory that you need to do only particular method. If they mentioned us to find out the standard deviation with actual mean, especially if they mention, then you can go with the actual mean method, or else anything can be applied, whichever is easy to you in the exam.
So shall we get full marks in that case by using any method?
Yeah, obviously. Why not? You'll be getting full marks even because they should get the answer. You should get the answer. Either it may be an assumed mean or actual mean. The answer must be same. There is no difference.
So when the answer is same, why should we go for all the different methods?
Because the thing is, when you are calculating with the assumed mean, so it saves the time. We are not calculating the mean and applying it. So directly we are assuming something as a mean and we are calculating and finding out the value. So there is a time reduction. We can reduce our time and we can calculate directly.
Okay.
So that you can apply the technique. No, you are comfortable with the actual mean, you can go with the actual mean. But it takes some time, additional time to be consumed. After calculating the mean only, you are doing it. Like if it is the step deviation method, I won't put even the calculator also in front of me. Directly we can calculate. Like in the from the class interval, we can find out the mid value easily as the difference divided by 2. Then from this mid value, we'll assume something as a mean and we'll calculate the d. Then fd dash. Fd dash, if we'll calculate, means this d also divided by c or an I, if we calculate, it reduces, and if we multiply it, easily you can get it. So that reduces the time. That's enough. Nothing else. Right? This is the method here. D dash. So this d is divided by the class interval difference, that is 20. If you divide it by 20, you'll be getting a d dash as a dx or d dash, whatever it may be, you can call it as d dash f into d dash f d square. Easily calculated, and you can apply the formula quickly. You can do this calculation part easily. That is the advantage of step deviation method, and that is applied only when there is an equal class interval difference. Equal classes, then only you can apply that one. Okay, for the day, what we discussed is about quartile deviation, range, standard deviation. So based on this only, we'll be having further methods like finding out the skewness or a correlation regression, which is there in the 5th module for you, that we are going to complete it first. So in the next class, we are going to discuss that one with this combined standard deviation also. So standard deviation, quartile deviation, and the range, mean, median, mode. You practice these things because you have an exercise problems in your material. In every topic, you are having an exercise problems. You go through it, find out the solutions for that one. Okay. Okay. Done for the day. Meet again in the next class. Right.
Okay, bye.
Okay, that's all.
Okay. Thank you.